I'd like to start by looking back in time to 1955. And this was when President Eisenhower first proposed the ship in this picture, which is the NS Savannah. Now, this was the very first nuclear merchant ship, and it was proposed to show the peaceful application of nuclear power. And it did this. It even docked in New York Harbor, where tourists were allowed to walk around the vessel and have a look at the luxurious staterooms. Now, that might have given you a clue that it wasn't particularly meant as a cargo ship, although it could carry cargo. But it was more of a technology demonstrator. It showed that you could put a nuclear reactor in a ship and operate it in a safe and controlled way. Now, interestingly, since this, in the last 60 years, there's only been 3 more attempts at nuclear merchant ships with varying levels of success, most kind of falling down on the economic side of things. But perhaps the economic climate is changing. Perhaps the world climate is changing. And the industry may look to nuclear shipping once more as a potential solution. So in this presentation, I'd like to talk about 3 issues. 1, why might we need nuclear merchant ships? 2, what are the potential issues with a nuclear merchant shipping industry? And 3, what potential solutions might we have to see before the industry is accepted and allowed to go forwards? Okay, so the first question, why might we need nuclear ships? I think this really comes down to 2 issues. One is the economics, and I'll come on to this in a moment, but the other is the environmental side of things. So you might say, well, actually, transporting goods by sea is very efficient anyway, so what's the problem? And you'd be right. I mean, if you say you wanted to transport the same amount of goods by rail, you'd have to use 5 times as much energy. If you want to transport the same amount of goods by road, you'd have to use 50 times as much energy. If you ever tried to get off a small boat and you've fallen between the gap between the boat and the jetty, you'll know that you can actually move fairly large objects through water with small forces. And shipping really takes advantage of this. You tend to have very large ships with huge capacities being propelled through the seas. Okay, so what's the problem? The problem really is the size of the industry. More than 90% of world trade is now being transported by sea, and this is all starting to add up. We're starting to see that shipping now accounts for 2.7% of global carbon CO2 emissions. So I think in the past, shipping has managed to stay under the radar a little bit because it's so much more efficient than its nearest alternative. But I think now the environmental finger is starting to point at shipping and saying, you need to improve your efficiencies and reduce your air pollution. And the industry is starting to respond and look for ways that you can do this and become more environmentally friendly. I think nuclear power offers you an advantage here. Not only does it produce no emissions during operation, but it actually makes very efficient use of the fuel. This is because it accesses the energy within the atom rather than the chemical bonds between the atoms, as fossil fuel does when you burn it. So this means that in 1 gram of uranium fuel, you have 2 million times as much energy as 1 gram of fossil fuel. So it certainly offers quite a few advantages from an environmental point of view. Okay, so looking at the economics, this is really dominated by the price of oil. The reason for this is because with traditional shipping, their costs are really dominated by their fuel costs. That's their main issue, and that's obviously closely related to the oil price. I think if you owned one of the Maersks, which is the largest container ship in the world currently, and you wanted to make a trip from Europe to Asia, you'd actually have to fill 10 squash courts with fuel to make that journey. Now, if you imagine how expensive it is to fill up your car, this obviously represents a huge amount of money. Okay, so what about the oil price? It really does 2 things. I think in recent history, it's been steadily increasing. And this means that the through-life costs of shipping is steadily increasing as well. Now, you can see at one point in the future, if this trend continues, you may see a situation where nuclear is actually cheaper through life than your existing shipping. And then the industry, being very cost-dominated, might look to nuclear shipping as a potential solution. Okay, so the second thing the oil price does is it fluctuates quite a lot. And this is an issue for the shippers because they tend to set their rates, their spot rates, their fees essentially for carrying the cargo quite far in advance of the voyage. So they're really at the mercy of the oil markets when they come to fill up. You can see here that in the 2008 oil crisis, the price of oil can actually spike quite rapidly. And this is really going to hurt the shippers. This is going to hurt their operating costs and their bottom line. So I think from this point of view, you might see that the shipping companies actually go to nuclear shipping perhaps before it's truly profitable, just because they're looking to really stabilize their operating costs and provide a more kind of stable business. I think the final nail in the coffin for existing shipping is when we become, or when oil starts to run out and become scarce. I think in this situation, you'll see it being reserved for critical services like power generation and certain types of air transport. I think shipping will lose out here, and they'll have to look for alternative ways to generate power. And there's actually not that many options, nuclear being one of them. So perhaps this will force the hand of the industry, and they'll have to look to something like nuclear to be able to carry on with the shipping industry. Okay, so that's why we might need nuclear ships. The second question is, what problems face nuclear ships? Now, in the world fleet at the moment, there's more than 1,000 large container ships. So you can see that in certain scenarios, you could actually have a very large number of nuclear ships bobbing around the oceans, perhaps several hundred. So this is obviously going to cause a large number of social and political issues, which will have to be overcome before the industry is accepted. Okay, so the first one, port access. Which countries would allow these nuclear ships into their ports? And this also raises the question of, would you be happy if you live near a port and there was a nuclear ship coming and docking? I think I'm okay living in Derby, but if I lived near Felixstowe, it might be a different issue. It also raises the question of which countries will be involved. Countries like Australia have said they want nothing to do with nuclear, so you wouldn't be able to trade with them. I think you'd struggle to avoid China at the moment, and that's because China has 16 of the 30 largest ports in the world and is responsible for a large amount of world trade, although that may change in the future. The regulation is interesting. If you consider the regulation of commercial power plants at the moment, it's actually not comparatively, it's not too difficult because these plants don't move very fast. In fact, they don't move at all, so you can keep track of them. These ships could go anywhere in the ocean. This includes international waters and the territorial waters of several different nations. So the question of who would take responsibility for the ships when they're in these different areas is an interesting one. It's unlikely that one nation would want to take responsibility. So perhaps you'd have bilateral agreements, or perhaps even an international body would actually take on this charge. Yeah, the design is interesting because current ships tend to be fairly simple. I mean, if you think of them as kind of large bathtubs with an outboard motor on the back, you're not kind of too far wrong. I mean, don't get me wrong, some of them are quite complex and they're certainly very large. The largest ones you can actually fit nearly 4 football pitches on the top of them. But if you compare this to a nuclear ship, the nuclear ship would have to be highly integrated. It would have to be a highly integrated system that takes account of the whole vessel. So you wouldn't just have the power plant kind of independently on its own. I think this would require a step change in the way that the design industry thinks and the kind of philosophies that they use to design. The reason for this is because at the moment you tend to have everyone in the shipyard. You have the ship owner, you have the machinery suppliers, and everyone's really kind of talking to everyone. I think for a nuclear ship, you'd have to have a system integrator. You'd have to have someone that's taking control of the whole ship and ensuring that everything is done in a safe and really reliable way. It's the same for operation as well. Operation of a diesel tends to be fairly simple. Obviously, a reactor is a completely different beast. It's quite difficult to operate. But perhaps it doesn't have to be. Perhaps you could have a reactor that's got a large amount of automation in it, and it's effectively a black box. So your ship's crew can turn it on, they can power it up and power it down, and turn it off without too much qualification and experience. I mean that would require another kind of step change in reactor technology, perhaps. But it might be that it's something like this that's an enabler for the industry, because the other option is that you have to train up all of your ship's crew, your ship's captain, and they all have to have an understanding of nuclear, as well as, say, your port authorities, your port inspectors, and all the other people around the industry as well, which would be a significant undertaking. We can't forget the bad guys, the pirates and the terrorists. We've got to stop them being able to get to the nuclear fuel. Not only this, but we've got to be able to stop them taking control of the ship, because, for example, they might be able to drive it into a populated area in a malicious way, or drive it into a densely used shipping channel and cause problems that way. So that's something that's got to be carefully assessed and included in not only the design of the reactor, but the design of the ship as well. Okay, so everything that you build, unfortunately, you have to dispose of, and nuclear ships won't be any different. I think that the way that current ships are disposed of tends to be fairly simple, again. So you tend to be kind of driven up onto a beach and pulled apart. And obviously, this wouldn't work for a nuclear ship. You'd have to consider the decommissioning. And you'd also have to consider how the spent fuel is managed. If you think this would be an industry operating between many different nations, and who would take responsibility for all of that spent fuel? If you think earlier I said, there could be several hundred of these, I think it's a really interesting question because, no one's really going to want to take responsibility for that and include all of it. So that'll be interesting as well to see how that develops. Okay, so we've looked at what are the potential issues in terms of the social and political issues. So maybe to actually see the industry take shape, we'd have to see maybe a different philosophy in terms of the way that the industry is constructed. Maybe we'd have to see some sort of novel solutions before the industry is acceptable. So we've got a couple here. I mean, if one of the issues is that the nuclear ship can't go into a port, then perhaps you could have a bespoke nuclear port away from a populated area, where the nuclear ship arrives, unloads all of its cargo, and the cargo is transported to the populated areas using high-speed rail. Another solution here is that you could have an offshore terminal, so that the nuclear ship will unload all of its cargo onto the offshore terminal, and you have perhaps a smaller fleet of smaller vessels that then transport the cargo into the port that aren't nuclear. So I think both of those potential solutions will actually hurt the economic case. You have to spend more money to see them take shape. And this isn't good for the nuclear merchant shipping industry. You'd actually want to see a cheaper solution. You want to be cheaper than the fossil fuel alternative. So one way you might be able to improve the economic case is if you generate electricity in port. Now, you'd never do this with a fossil fuel ship because you'd be wasting your valuable fossil fuel. But if you have a nuclear ship, the actual fuel is a very small part of the overall life cycle costs. The main life cycle cost is in the actual initially buying the reactor in the first place. So if this is the case, you could actually carry on generating power in the port and sell the electricity back to the grid, for example. These ships aren't small. I mean, the Emma Maersk is around 80 megawatts, 80 to 100 megawatts. And if you consider that's about a tenth of a power station, we're not talking about insignificant amounts of energy. So that could potentially work. Now, I think all of these solutions are kind of possible, and there'll be many more as well. But just to summarize, I think there's many challenges facing the industry that need to be resolved before it's acceptable. But I think there's many opportunities to be novel and to think about the industry in a different way. If you look at the other side, there's actually quite a few drivers as well that might push you towards nuclear power. For example, the economic side of things, if the price of oil carries on increasing, and the environmental lobby as well that may push the industry away from burning fossil fuels and using alternative power sources. I think whether we see this industry in our careers or our lifetimes, I don't know, but I think it'll be very interesting to see how the industry develops and how these potential issues and problems are overcome. So thank you very much. That was my presentation. And are there any questions?